Hello guys, so in this video we are going to be solving the popular LeetCode problem, valid anagram. So let's go through the problem. Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters of exactly one. So anagram is basically just rearranging a string in a different order. um but all the letters are going to be there. All the letters are going to appear typically exactly once, so each letter will appear exactly once, or each character in the string will appear in the other string exactly once. So if you look at an example one, we are supposed to return true if s and t are anagrams. um S is anagram and T is nagram. You notice that S has three A's and T has three A's. S has an N and T has an N. S has a G, T has a G. S has an R and T has an R. S has an M and T has an N. So they basically have the same characters with the same number of occurrence, but the order doesn't really matter. So they are anagrams of each other and we return true. The next one, you have S, which is rat, and T, which is car. You notice that S has a T and car doesn't. Car has a C, so we return false because they are not anagrams of each other. So some of the constraints: one is less than or equal to s dot len comma s dot len is less or equal to 10 to the power 5 times 10 to the power 4. So this simply means that our strings are not going to be empty. It's always going to be in the range from 1. The length of the string is, our strings are always going to be from the length of 1 to 5 times 10 to the power 4. And our strings are always going to have lowercase English letters, so we are sure of that. And we have a follow-up here. um the follow-up so I have a follow-up here. The follow-up says, that what if we used sorry, what if the input contains unicorn characters? How would you adapt your solution to such a case? So basically, here we could use a hash map instead of using a fixed counter size. So when we're going to walk into a solution, we are going to look at how that goes and you understand better. So let's dive into a couple of ways in which you can solve this problem. So one very simple way in which you can do this is simply by sorting, right? So if we have s, if we sort s and then we sort t, you notice that if we sort s and t alphabetically, you notice that s and t are going to be the same. They are going to be the same string at the end of the day. So if you sort those two strings alphabetically, they are going to be the same string at the end of the day. Let me scroll back down to this. So if you look at this and we have to sort these two strings, you notice that s becomes a g m a r, and t will probably be the same thing, g m a r. And at the end of the, and you notice that these two strings are equal. So if we sort them alphabetically, we can now check for equality and we will return true if the two strings are equal. So if t is exactly the same as s, if the two strings are equal, then we can return true. So this is a very simple way of doing this, but the problem here is is the time complexity of this is on log n. Because we are sorting a string, so it will be probably om log m plus on log n. So the time complexity for sorting this is om log n, and the time complexity for sorting this is still om log n. So that together, all of that is the same thing. And the space complexity, mm, and the space is off, and because we are building a new string, which is probably the length of the input string n. So we're building two new strings s and t, which are the sorted strings of our input strings. So yeah, this is what we can do at the very beginning, at the very simple step, in a very basic manner. But we can improve this using a hash map. uh so basically, what can we do? We can create two hash maps and compare them. So we can create a hash map of this and create a hash map. We can create a hash map, sorry, we can create a hash map of for s and create a hash map for t, and then compare them and see if they are the same. So assuming we have our string s and t. And what are some of the first thing we can do immediately? We can check the length, because we are sure that if if the length of these two strings are not the same, then they can never be anagrams. So probably one has more characters than the other. So we can check the length straight ahead in the beginning to check to see if the lengths are the same. If the lengths are the same, then we can go ahead and do some more work to check if they're actually anagrams. If the lengths are not the same, then we can return false immediately, because we are sure that they are not anagrams. So if the lengths are the same, what are we going to do? We are going to build a hash map. So we are going to simply look to one of these strings. uh so while going through this string, we are going to build a hash map, two hash maps actually. So we are going to have a hash map t and another hash map s. So what will these hash maps contain? T is going to contain the characters as key and the number of occurrence as the value. Same thing with s, the characters as key as the number of occurrence as the value. So if I'm looping through the first string s, so let's just say s, as I'm going through that loop, I can loop through just one of these strings, since I already checked initially that they have the same length. So I won't have a problem with that. So if I'm looping through one of these strings, I will start with the first one. So if I have a n a g r a m, and when I go to a, this is what I do. I will loop through this and I start from here, and I'm going to come and check in my starting with s, right? I'll simply check here and see if this a or this character is inside this hash map. If it is not there, then I'll simply add it here and I'll initialize its value or its occurrence to 1, and then I'll move to the next character and do the same thing and check if it's there. If it's not there, I'm going to put it here and initialize its occurrence to 1. I'll do the same thing with this other a and check. Oh, I see that a is there. I increase its occurrence by 1, so it becomes 2. And then I do the same thing with g. You notice that the g is not there inside the hash map, so I'm going to put it there and initialize its occurrence to 1. Same thing with r. Okay, initialize its occurrence to 1, and another a, I'll increase the occurrence to 3. Okay, and m, I will initialize its occurrence to 1. So I've gone through this array, this string, sorry, and I've created a hash map of the characters and their occurrence as key pair values. So the characters and their occurrence as key and value pairs. So I can do the same thing with basically the same thing with the other string. I'm going to check each value here. So you notice that if I check n, I will have n as 1, a as 3, r as 1, and g as 1, and m as 1. So at the end of the day, you notice that these two hash maps are equal. So checking if the hash maps are equal, you have to check if hash maps are equal, you check if each key value pair here matches the same key value pair. So you notice that A is present and has a value of 3, A is present and has a value of 3 here. R is present and has a value of 1, R is present and has a value of 1 here. M is present and has a value of 1, and M is present and has a value of 1 here. So you notice that each key value here maps a key value in this other hash map. So at the end of the day, you notice that if actually the two strings are anagrams, when we build a hash map of them, then they are going to be equal. The hash maps are going to be equal. From that, we can now check if the hash maps are equal and return true. If the hash maps are not equal, we can return false. Um, One thing though, when adding a value in a hash map, the time complexity for this, okay, is O of 1. If you are adding a value in a hash map, we are checking a value in a hash map, the time complexity is still of 1, so constant time. So that's one good thing about the hash map that we can utilize to make our code more efficient, to make our code faster. So, but the total time complexity of this particular algorithm would be O of n, simply because we are looping through this string. Potentially, we are going through this string, um, which is we has a length of n, which is potentially the length of the input array, of the input string, sorry. And the space complexity of this is O of n, simply because we are building two hash maps that are going to take the length of the input string. So yeah, and this is a much better solution compared to the initial solution we did. There is a solution with time complexity of 1. um I think because of the follow up we had in the question, I don't think I'm going to implement that here, and because also because this is going to be a very long video also. So let's see how we can go ahead and implement this solution in code. Yeah, I would also love to hear your idea on the different types of solutions you have, um, and probably see how you did this in a different way. Okay, so let's implement this in code. So yeah, let's go ahead and write the code for this. So the first thing we can do basically is to first of all check if the lengths are not the same. So if the two strings don't have equal length, then we can simply return false, because we are sure that we can return for them because we are sure that they can never be anagrams. Okay, if the two strings are not having the same length, we can simply just return false. And then from there, now if the two strings have the same length, then we have some more work to do. We can go further and check if they are actually anagrams. So we'll start by building our empty hash maps. We start by creating our empty hash maps, and then we can loop through. I'm going to loop through one of these strings. It doesn't really matter because we already know that the strings have the same length. So I'll simply loop through s, and I'm going to build the hash map as base of what I got from the string. So I'm going to build the hash map. So the keys inside s will simply be the characters in the string s, and that will be equal to that will be equal to a value, or the value of the key in s if it already existed, okay, or simply 1. So what this does is, first of all, we'll get this key si, which is basically the character in s, inside this hash map, and we get it, or we return. This is a very good, this is a nice this is a good method in Python that we use to get keys, or the value of keys in an object or in a hash map. um This will simply return 0 if the value is does not exist, but if it exists, it's simply going to return the value. So initially, if the value does not exist, I'm going to have 0, and then I'll simply add it to 1, and I'm going to initialize it as the key of that particular as the value of that particular key in the hash map. And then I'm going to do the same thing with the hash map t. So yeah. So after building the hash maps, we are quite sure that if these two hash maps are the same, then we simply need to return true. So it's going to return true if s is equal to t, and false if not. This is going to return true if s is equal to t, and false if s is not equal to 2. T. So let's go ahead and run this code, submit this. I'll go ahead and submit this and see the results. Yeah, so this is pretty efficient, even though it doesn't reflect that very much here. And it shows I'm using quite less memory. Anyway, so okay, guys, thank you very much for being there. Thank you very much for following this video. I hope it was helpful. Um, if you like what you're seeing, if you like this video explanation, please like, share, and subscribe. You can connect with me on LinkedIn. I share a lot of articles and tips and tricks on programming on LinkedIn. So yeah, thank you very much. See you in the next video.